All right, this video is going to be on graphing radical equations. Pretty simplistic, pretty straightforward. You can take notes on your own sheet of paper for this. You don't necessarily need a notes page. So we're going to start off on number 4. The way that I look at this is I look at opposite of the inside, keep the outside. Opposite of the inside, keep the outside. And if you're used to doing equations, this is the same thing on everything. Opposite of the inside, keep the outside. That's the same thing on doing quadratics, everything pretty much. Opposite of the inside, keep the outside. So when we're looking at this, opposite of the inside is going to be positive 3, keep the outside positive 2. That tells you the starting point for these type of equations. So we're going to start at 3, 2. Now, here's the deal. Think about a square root. Think about what you cannot have underneath. For us to be able to graph it, it has to be a real number, which means we cannot have a negative number underneath the square root. Otherwise, that gives us an imaginary number, which will not graph on this plane. So we need a real number. Well, this 3 will give me a 0 underneath, which means anything less than 3 is going to give me a negative underneath the square root, which doesn't exist. So we're going to be moving to the right. So we start at 3, 2. And now we're going to be graphing values to the right. So let's just plug in 4, 5, 6. And you can type this into your graphing calculator and get an equation. Look at your table. I'll run through this really quick right here. So that will give you a value of 3. 5 minus 3, square root of 2, it's like 1.4. So this will give you like 3.4. Square root of 3 is like 1.7. So we'll call that 3.7. Square root of 4 is 2. 2 plus 2 is 4. Again, type it into a calculator. Get all your values right here. So 4 is at 3. 5, 3.4. 6, 3.7. 7 is at 4. So this thing is going up, and it's making a nice little smooth curve, kind of starting to flatten out, but it's not quite going to flatten out. All right, so that is your function. Doing domain and range of these is pretty simplistic. Domain is from 3 to infinity. Okay, our starting point to infinity. Our range is from the lowest value, which is 2, and it runs to infinity. Notice I'm including brackets because those values are included. Okay, the only time that it's going to flip and go left is if there is a negative underneath the square root. If there's a negative underneath the square root, that's a reflection across the y-axis, which is going to make this thing go to the left. So keep an eye on that. Let's look at another problem. Let's look at 2 times the square root of x minus 1. Again, hit pause. I want you to find the starting value on your own this time. So find the starting value of this. All right, hopefully you have done the opposite of the inside, keep the outside. Opposite of the inside is pretty simple, 1. Now on the outside, there is a 2, but it's not being added, it's being multiplied. So we just kind of ignore that. And the outside, there's nothing out there, so 0. So our graph starts at 1, 0. Now, plugging in some values to the right, 2, 3, 4, 5. It doesn't matter how many you go. I would at least go 3 or 4 values just to make sure you get a decent graph. All right. So this is 2. 2.8. That'll be a 4. I think this is going to be like a 3.4. All right. Again, type it into your graphing calculator to get your values. 1, 0, 2, 2, 3, 2.8, 4, 3.4, 5, 4. So you can see this one's growing at a little bit faster of a rate due to that 2 that was on the outside. Domain and range, look at your values. Your x value is 1, so we're going from 1. Oops, 1, 0 is right here, isn't it? I don't know why I graphed 1, 1, my mistake. So it should look like that. So 1 to infinity, your range is going to be 0 to infinity. Okay? All right, I want to do one more type of problem like this with you. Looking back up to a problem like this. This one looks just a little bit different, but it's really simple. The plus 1 or the negative 1 plus the square root of x is just rote or written a little bit differently than what we're used to, we can rewrite this as the square root of x minus 1. Okay, so your starting value is going to be at 0, -1, and then you do the same exact thing. Draw your t-table and draw it out. All right, so that's how we graph square root equations. Graphing cube root equations is honestly the same exact thing. So if we look at number 9, or actually, let's see. See if I have a better example for you. All right, let's look at number 11. So we're going to do opposite of the inside, keep the outside. Opposite of the inside is going to be -4, keep the outside -1. Now, here's something that's different. Think about a cube root. We can take the cube root of a negative. If you take the cube root of a negative, it works out just fine. So, instead of sticking it at the top of our table, we're actually going to stick -4, -1 in the middle of our table. This is going to go in both directions. Now, for those of you that don't know how to find the cube root on a calculator, you hit math, and then if you see number 4, right there, that's cube root. So cube root, and then we have x plus 4, make sure you close your parentheses, -1, and then we can look at our table. We said -4, -1 is our starting value. And then let's just do a couple of values around it. So like -5, -6, -3, -2. All right, look at your table over here. -4, -1, -3 is at 0, -2 is at 0.26, -5 is at -2, and then -2.26. All right, so now we plot these values. And this one makes like a little S, like a snake type symbol. Okay, so cube roots, same exact thing as square roots. Take the opposite of the inside, keep the outside, except this time we're actually going to graph it in both directions because cube root functions can be negative, which allows us, this would be our square root. Cube root actually goes in the other way in a mirror image. Okay? Hopefully this cleared everything up for you as far as graphing square root and cube roots. If you have any questions, let me know. Looking at this one real quick, notice that there's nothing on the inside, so this would be a starting point of 0, 3. All right, go for it.